In this lesson, we're going to talk about solving for a variable in terms of other variables. Specifically, we'll apply our understanding of solving linear equations, and we'll actually solve for a variable in terms of other variables. A couple notes before we get started. I encourage you to underline the variable that you are being asked to solve for, and then you treat that variable like you would solving for x in a linear equation that contains numbers. So example 1, we'll compare side by side solving for x when we get a number and solving for x in terms of other variables. So with the equation on the left-hand side, when we have 6x minus 9 equals 21, we're being asked to solve for x. In this case, we would add 9 to both sides. Okay. 6x comes down. Negative 9 plus 9, these cancel out. Then we have our equal sign. And this is very important. On the left-hand side, 21 and 9 are like terms. You can add $21 to $9. Okay? So 21 plus 9 is 30. So we end up with 6x equals 30. Moving to the equation on the right-hand side, we have 6x minus y is equal to z. Okay? We're still being asked to solve for x, but instead of having a number like minus 9, we have another variable, minus y. In this case, we'll add y to both sides, okay, and I'm going to write it horizontally, and we end up with 6x, negative y plus y cancels out, and on the right-hand side, z plus y is just z plus y. These are not like terms, so we cannot add them together to create one term. We leave it as z plus y. Back to our equation on the left, 6x equals 30. We divide both sides by 6. 6 divided by 6 is 1. We have x equals 30 divided by 6 is 5. So we end up with a number. On the right-hand side, we have 6x is equal to z plus y. Okay? We're still trying to solve for x. And in this case, we still divide by 6 because we want to get x on its own or find out what 1x is equal to. So we divide by 6 and we divide by 6. Remember, what you do to one side, you have to do to the other because there's an equal sign because of that equation. 6 divided by 6 is 1. So we have x is equal to z plus y over 6. We can't combine those terms. On the left-hand side, 30 divided by 6 is 5. In this case, z plus y divided by 6 is just z plus y divided by 6. So that's to show you that you can use your knowledge of solving linear equations when we're finding the exact value of x to solving for a variable in terms of other variables. Let's go through a couple of examples. Solve for the indicated letter. For part A, we have A is equal to L times W. So we're solving for L. So I'm going to underline it here so we can keep track of our letters. L is being multiplied by W. Okay, so if we want to get L by itself, we have to get rid of the W. In this case, since W is being multiplied, we'll divide by W on both sides. Okay. W divided by W is just 1. So our final answer here is A over W is equal to L. Note that computer software is picky, meaning since these are all capital letters, when you enter your answer, you have to enter capital letters as well. Moving on to part B, we're being asked to solve for lowercase w. I'll circle it this time. And in this case, we have w divided by k times x is equal to y. So notice that in this case, the denominator is in our way. This is division. So in order to get rid of or undo that division, we use multiplication, where we're going to multiply kx on both sides. So on the left, they cancel out, and we're just left with w. And on the right-hand side, y times k times x is just y times k times x. Example 3, solve for the indicated letter once again. So for part A, we're solving for B. And this is similar to the example we did with the side-by-side comparison. We subtract 9c from both sides, and now it might be helpful to write your work out horizontally or longways rather than stack on top of each other, so that you can see what can combine and what's being added together here. So I'm going to subtract 9c from both sides. So on the left-hand side, we have 5b. We didn't do anything to that yet. Positive 9c minus 9c cancels out. We have our equal sign. Oops, that should be a minus 9c. And then we have a minus 9c. Again, these are not like terms, so it just stays a minus 9c. Next, we're still being asked to solve for b. That 5 is being multiplied by b, so we divide both sides by 5. So we have b is equal to a minus 9c over 5. Now, one thing you can do, and I'm going to go up top here and show you another way to divide this. If we have 5b is equal to a minus 9c, rather than dividing the entire side by b, or by 5, I'm sorry, you can divide each individual term by 5. So what that looks like, that's too bright. Divide by 5, divide by 5. It's the same as dividing the entire side by 5 if you divide each individual term by 5, and you would have b as a over 5 minus 9c over 5. Okay, so either one of these answers will work. In example B, part B, we're going to solve for r. Okay. Again, we have a denominator to deal with first. A good rule of thumb, whether we're solving for a variable in terms of other variables or when we get into equations later on, it's always a good idea to get rid of denominators whenever possible when it comes to solving equations. Okay, so in this case, the denominator is 7. We're dividing by 7, so we multiply by 7 on both sides. The 7's cancel out, and we have r plus p is equal to s times 7 is just, I'm going to write it as 7s. And multiplication order doesn't matter. You can do s times 7 as well. And then we are solving for r. Since p is being added to r, we subtract p from both sides. And we're left with r is equal to 7s minus p. Thank you for watching this video. If you have additional questions, feel free to contact me or utilize the free resources that are available to you.